Okay, in this video I'm going to review the example I did and review an example of counting. And in this example what we're going to do is we're going to look at the relationship between lists and subsets. And we've shown that the number of k lists, or let me call them k permutations, and by using the word permutation that means we don't have repeats. The number of k permutations from an n set is equal to p n k, and we've shown that this is n factorial divided by n minus k factorial, and it's also equal to n times n minus 1 times n minus 2 all the way down to n minus k plus 1. And we were able to arrive at this expression on the right using the counting principle. Okay, and then on the expression with the factorials just says, well, this thing over on the right looks like the top part of n factorial, where we chopped off from n minus k on down. And so we turned it into n factorial, and then we let from n minus k on down to 1 cancel out by putting n minus k factorial in the numerator, in the denominator. Okay. We also showed that the number of k subsets from an n set, an n set is just an n element set, is Cnk. And this one's a little bit more complicated. And here we don't have distinct ordering in the subsets, whereas in permutations we do. And this one is n factorial all over n minus k factorial times k factorial. In other words, it's smaller than the number of permutations by a factor of k factorial. And k factorial is in fact exactly equal to the number of rearrangements of each of these subsets. So this is Pnk divided by k factorial, which can be interpreted as the number of permutations divided by the overcounting factor when we count permutations. If we want to count subsets, we can first count permutations and then divide by the number of different ways of rearranging each subset. And in this video I'll round that out by revisiting the example we had where we had n is equal to 5 and k is equal to 3. And we said, okay, so this is an n set, so I'm going to let my set be A, and I'm going to let it be A, B, C, D, E, let's say. And I'm going to now count the number of 3-element subsets from that n set. And let's suppose let me just take one of those 3-element subsets. Here's one of them. And I want to ask myself, how many permutations, if I counted the number of permutations, how many would I get from that? I would get 6, because there's 3 factorial ways of rearranging these things. And I can write ABC, ACB, BAC, BCA, and CAB, and CBA. So there are 6 ways of rearranging the elements in this subset that contains just those 3 elements A, B, C. In other words, there are 6 times as many permutations as there are subsets. There are 6 times as many 3-element permutations as there are 3-element subsets. And I can count very easily the number of 3-element permutations, and that's equal to 6. Let me use the counting principle directly. and that's equal to the number of ways of choosing the first one times the number of ways of choosing the second one times the number of ways of choosing the third. And these are permutations, so we don't have repeats in our list, and I have 5 and then only 4 left because I can't repeat, and then 3. And so I'm going to get 20 times 3, or 60 different 3-element permutations. But each of them, there are 6 of them. For example, these 6 over here, that correspond to a single 3-element subset. So the number of 3-element subsets is equal to 60 divided by 3 factorial, 60 over 6, or 10. Okay? And this is indeed equal to P 5, 3 for the 3-element permutations, and this is indeed equal to C 5, 3 for the number of subsets. And so one way to write down the power set, or the number, or all the 3-element subsets, is P3 of A. And one way to do this is to, and I'm going to write them down as subsets here. One way to do this is to keep them in alphabetical order, and that means that we'll never get any of these other guys. We're only going to get the one, say, at the top. We're only going to get 1 out of these 6. And if we keep them in alphabetical order, we're going to get 10 of them, and we're going to get something like A, B, C, A, B, D. I'm going to follow a pattern here now. A, B, E. I'm going to go out to the end now. A, B. First I started with just the A, B, and then I want C, D, and E. Next I'm going to start with A, C, and jump to D, and then AC, I can jump to E also. Okay, so we've got 5 out of the 10. Let's now do an AD, and the only one I can jump to is an E on that one. Next I'm going to start with a B, and I'm going to go to C and D. And then I'm going to go B, C, and jump out to E. And then, let's see, I'm going to go, I've done all the B, C, so I'm going to do a B, D. The only place I can jump to is E on that. B, D, E. And now if I start with C, there's only one way I can do it when I keep them in alphabetical order. That's C, D, E. And so that is the set of 10 subsets of 3 elements each of the set A shown above here. And putting them in alphabetical order is the way I did it on the board, and that's one way of making sure that we don't get any of those repeated permuted versions of the same subset. Okay? And so I'll leave it at this on this video. Well, I'm going to go ahead and write down all 60 of the permutations here real quick. I'm going to start with A, B, C. Now I can't repeat, but I can go A, B, D, A, B, E. I think those are all of them that start with A, B, aren't they? A, B, C, D, and E, yeah. Now I'm going to start with A, C. And what can I do with AC? I can go back to B. I can go A, C, D, and A, C, E. Now I can start with AD, and I can go AD back to B, AD to C, and then AD to E. And then I can go start with AE, and I can go back to B, AEC, AED. And I believe I've gotten all of those that start with A. I've got all the ABs, all the ACs, and all the ADs, and all the AEs. And you'll see now that I've got 12 of them. So 12 start with A. And then I can do the same thing for B, C, D, and E, and I will have 12 times 5, or 60. So I have 12 start with an A, 12 start with a B, 12 start with a C, 12 start with a D, and 12 start with an E, for a total of 60. Okay, I guess I didn't write them all out, but I think I'm going to stop the video here and leave it at that. And you can write them all out on a piece of paper, and I highly recommend doing that at some point here this semester. Okay, hope this helps.